All right, folks, in today's class, we are going to be finding the, oops, kicked my card. We're going to be finding the GCF of polynomials, and GCF stands for greatest common factor. So we need to find the greatest common factor in our quadratic polynomials, and we need to pull that out and rewrite our equation. And let me show you what that kind of looks like. Let's start off by thinking about our distributive property. In distributive property, we start off with something that looks like this, and we know that we've got to distribute this 2 to both terms inside the parentheses. So we take the 2, we multiply it all together. So 2 times 3x, 2 times 4, and we end up with 6x plus 8. That is distributive property. And what we're going to be talking about today with finding the greatest common factor is we're going to be talking about factoring. And factoring is basically the opposite of the distributive property. So we're going to start out with something that looks like this. So whatever we ended up with, we're going to start out with this, such as standard form, ax squared plus bx plus c. We're going to start out with this, and we need to take out the factors. So what we need to do today is we need to be thinking about and understanding what is the biggest number that can come out instead of going in. So let me remind you of what a factor is. So for instance, if we're looking at the number 24, these are all the different factors that multiply together to get you your product. So in this situation, here's our product, and we want to break down the product into its different factors and figure out which numbers we can take out. So if we take a look at this next step right here, so we see that 2 is common to both terms. It's a factor of both terms, and therefore we can take it out of the parentheses and put it here to the left of our expression. And this becomes the GCF, the greatest common factor. So we didn't really talk about this when we were multiplying everything together, that this was the greatest common factor, but it ends up being the greatest common factor, or a factor, in our final expression. But here we're going to be looking for the greatest common factor. All right, so let's talk about what that looks like in today's lesson. And in today's lesson, we are going to be taking stuff that looks like this, which is standard form of a quadratic equation, and different ideas or different ways to write that. And we're going to be doing a couple of things. So if you noticed in this example, so we started out with 2 terms, and we ended up with 2 terms, but we ended up with a greatest common factor on the outside of the parentheses. So if you notice, we start with 2 terms, and we have the same signs. This term here is positive, this is still positive, the 8 is positive, and this 4 is positive. So the number of terms and the signs are going to stay the same. We just need to pull out a greatest common factor. So step number 1 is to set up the answer format. So if I have my original expression, 32x squared plus 48x minus 16, when I factor this, I'm going to end up with the greatest common factor right here, and I'll actually label that GCF. And this is the first term, this is going to be the quadratic term, this is going to be the linear term, and this is going to be the constant. And the signs are going to stay the same. So there's still going to be 3 terms, 1, 2, 3, and the signs are still going to be the same. We're not taking out a negative or anything, we're just keeping the signs. So positive, and this one's going to be negative. So that's the first step. We got to figure out what our answer is going to look like. It's going to look like this. We just need to figure out what to fill in. Now the next step, step number 2, is to do a prime factorization by doing a factor tree. Now some of us are going to remember this from elementary school. Maybe we did it in middle school. But we're going to do a prime factorization, and it kind of looks like this. Let's start with this number 24. Okay, we're going to break it up into factors. Any factors you want. In fact, let me cover this one up and just so I can talk about this one. So right here, we're going to start with the number 24, and you need to find any numbers you want, any factors that multiply to get you 24. 8 times 3 is 24. So now, can 3 be divided by anything? Can 3 be broken apart? No, because 3 is a prime number. I'm going to get to that in just a second. 3 is a prime number, so it can't get any smaller. But 8, we can figure, what can we multiply to get 8? Oh, we can multiply 2 and 4 to get 8. Is there anything we can multiply to get 2? No, just 1 and 2. Those are the only things. What about 4? 2 times 2 equals 4. So this is our factor tree. We've broken it down into the smallest little bits. And here, if we circle 2, 2, 2, and 3, that becomes the prime factorization. Because 24, if we multiply this out, 2 times 2, 4, 4 times 2, 8, 8 times 3, 24. So we want to get down to the prime numbers, 2, 2, and 3. This is a reminder in case we've forgotten. Prime numbers can only be divided by itself and 1. And right down here, we've got a list of prime numbers. There's a long list of prime numbers, 2, 3, 5. What can we multiply to get 5? Just 1 and 5. What can we multiply to get 7? Just 1 and 7. 2 times 3, that's 6. 2 times 4, that's 8. Only 1 and 7 multiply to get 7. Same thing with 11. The only numbers you can multiply to get 11 are 1 and 11. These are all prime numbers. And for the most part, we're going to be kind of working down in this area. We're not really going to get into the bigger numbers. We're going to work our way down in our factor tree until we get to the smallest numbers possible, smallest prime numbers. So here we worked it down until I got 2, 2, 2, and 2. I can't factor these down into anything smaller. I can't break these down into smaller pieces. And this prime factorization, this works with any numbers. So if we stick with 24, there's a lot of different ways to get 24. For instance, 6 times 4. 6 times 4 is 24. Can I break 6 down into something smaller? What can we multiply to get 6? 2 times 3. What can we multiply to get 4? 2 times 2. Oh, but look, our prime factorization exactly the same. 2 times 2 times 2 times 3. So whatever numbers you start with, whatever your initial factors are, it doesn't really matter as long as you keep going until you get to prime numbers, and that's going to get you your prime factorization. So let's do it with this example and see what we get. So we've got 3 numbers that need to be factored. So what are some numbers that multiply to get you 32? 8 and 4 get you 32. 8 times 4. Now what numbers can I multiply to get 8? 2 times 4. All right, let's stick right here. This 2 is a prime number, so I'm going to circle that. 4 times, well, what can I multiply to get 4? 2 times 2. 2 are prime numbers, so I'm going to circle those. What can I multiply to get 4? 2 times 2. All right, that's good. Now, what can I do to get 48? What numbers get 48? What numbers multiply to get 48? 6 times 8. 6 times 8. What numbers multiply to get 6? 2 times 3. And we know that these are prime numbers. If you need to write down this list of prime numbers, if you need to write down the first couple of prime numbers here, you should do that. You might want to pause the video right here and write these numbers down so you know what you're looking for. We're looking for prime numbers. Okay. What 2 numbers can I multiply to get 8? 4 times 2, that's a prime number. And 2 times 2 equals 4. Now, 16. Now, we're not worried about the negative because the negative is going to be right down here. What numbers can we multiply to get negative? Or to get 16, I'm sorry. 2 and 8. Well, 2 is a prime number, so that's good. 4 times 2, that's a prime number. And then, oh, sorry, not 2, 4. I'm looking for 2. What numbers can multiply to get 4? 2 times 2. So I'm going to circle those. Now, that's our prime factorization. That's what we've done. Now, if we take a look at right here, what do we have right here? We've got x, and that's x times x. Right here, we've got x, that's just 1, and there's no x's right here. So these x's, we can't leave those alone because that's going to be important because maybe in another example we do here in a second, we can factor out an x as well. But I don't want to get ahead of ourselves. So we've done the prime factorizations, we've done our factoring tree, but let's kind of think this through for a second, and let me write down, here's the quadratic term, here is the linear term, and here is the constant. And let's write out the prime factorization for 32. It's this one right here. 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there was 2 x's. Don't forget your x's. Okay. Now, let's write down the one for 48. The prime factorization is 1, 2, 3, 4. 4 2's. And a 3. A 3 right here, and there's also 1x. Now, for the last number of 16, 2 times 2 times 2 times 2, so that's 4, 1, 2, 3, 4. Now, right here, ladies, and there's no x's. So here, ladies and gentlemen, to find the greatest common factor, we're going to circle everything that's the same. We're going to circle everything that's the same. So this is the same. We're going to circle everything they have in common. So it's all right in here. Look at this. They all have this in common. Every number here has this. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. The greatest common factor for each one of these is 16. The greatest common factor is 16. Whatever they have in common, remember, when we did our example with factoring, we're going to pull out whatever number they have in common. And what these two numbers had in common was 2, so we pulled that out. All of these numbers, 32, 48, and 16, have 16 left over, or have a 16 in common. So 16 is the greatest common factor. We'll write it right there. Now, what's left over for the 32x squared? I've got a 2 and an x squared. So I'm going to write it right there. This is the leftovers. What's left over for 48x? 3x. And then interesting, let's think about this for a second. This one's a hard one. What's left over right here? It's not 0. I know you're thinking 0 because there's nothing there, but look, how do I go from a negative 16 to a 16? What number has to be right here in order for this to be a negative? In order for this to be a negative, there has to be a 1 right here. Because 16, think about this, if we distribute this, 16 times negative 1 would be negative 16. So a way to check your work would be to distribute this and see if you come up with the original answer. So we found the GCF, the greatest common factor. That's everything that had in common. And I'll write that right in here. That's what's in common. And then the leftovers are everything that's left over right here. And we wrote for each term, we just wrote what's left over. And again, the tricky one's right here. There's a negative. The term was negative 16, and 16 is what was common. But what do I have to multiply in order to get negative 16? There needs to be a 1 right there. So this is the factored expression of standard form. This is going to come in. This is going to be important over the next couple of days as we start learning how to solve for x and figuring out what this number is right here. Just like we did with the linear function, we had to solve for x. We're going to do it with quadratics as well. So this is an important first step, finding the GCF in order to solve for x. Let's do one more example. This one's going to be slightly different, but the same. So we're going to set up for our answer. And remember, so we're going to pull out a greatest common factor. There's 1, 2 terms. And what's in between these terms is addition. So that's what my answer is going to look like. I need to make our answer fit this. We're going to do the prime factorization with the factor tree. All right, so what two numbers multiply to get you 15? 3 times 5. Oh, let's look at our prime numbers again. Look at that. 3 and 5 are prime numbers, so I'm going to circle those right there. That's good. And then what do I have to multiply to get 20? 4 times 5. And then 5 is a prime number. What do I multiply to get 4? 2 times 2. Prime number. I've got 2 x's here. X times x is x squared, and I've just got 1x. So let's write this out, our terms. So now we're finding the GCF by writing out our prime factorizations and figuring out what is the same and what is left over. So here we have 3 times 5 times x times x. Here we have 2 times 2 times 5 times x. Right? Okay. So what do they have in common? Well, there's no 3's. Oh, here we have a 5. That's common. And look, both of these have an x. So the greatest common factor is 5x. What's left over? 3 and an x. So I write 3x. What's left over here? 2 times 2 is 4. So I found the greatest common factor, I found the leftovers, and I wrote my answer. Now, if I multiply this out, if I distribute it, 5 times 3 is 15. X times x is x squared. 5 times 4 is 20, and I've got an x. And look, that's my original expression. So factoring the greatest common factor, we set up our answer format so we know what to look for. We do our factor tree. We list out all of the prime factorizations. We figure out what is common. in all of our terms to find our greatest common factor. We find the leftovers, and we write the leftovers inside the parentheses. And there you are. Finding the greatest common factor of polynomials is these 5 steps. Now let me show you a calculator trick, a way to help us do this work right in here. So let me go to Y1. Let me clear all this out, and let me show you what we need to do. In order to use the calculator to find your greatest common factor, we want to go to your Y1, and in Y1 we want to type in the quadratic coefficient, 15, and we're going to divide by x. We're going to go to Y2. Actually, let me do the first one because there's more numbers there. Let me do the first one. Clear. So we're going to do the first one here. So this is 32. So 32 divided by x. 48 divided by x. And then negative 16 divided by x. And we can hit enter. And we don't want to look at the graphs of these. We actually want to look at the tables. Second table. And what we have here are the x's. Here's y1, which is this coefficient. Here's y2, which is this coefficient. And in y3, so we have to scroll over. Y3 is right here is the 16. So let me show you the scrolling that I'm doing. So scrolling left and right allows me to see y1, y2, and y3. And here's what we're looking for. We want to find the smallest coefficient, which is the 16, which is y3. We want to scroll all the way down until we get to 1. Here it is, 1. And then what we want to do is we want to find the last row. This is as far down as we go. The farthest down we go is the smallest coefficient all the way down to 1. Our answer is somewhere above this line, above 16. So let's or it's at 16 or above. So let's see what we need. The smallest row of whole numbers. So we got a whole number here. See, there's all these decimals right here. There's a whole number, but we don't see y1 right now. So whole number. Let's scroll over. Oh, look at that whole number. That's good. So what this tells us is that this is our answer. Let's take a look at what this gives us. This says 16. Let me write it right here. This says 16. This says 2. Oh, does anybody see it yet? 2. 3, and let me tab over, 1, negative 1. Wow, look at that. The calculator told us what the coefficients are for each term in our factored expression. Wow, look at that. That's pretty cool, huh? So the x column becomes the greatest common factor wherever we have the lowest row of whole numbers. So right here, we have y1, which is where we put our quadratic term, which is where we put this information, the 32. Y sub 2 is where we put the 48. And y sub 1 is where we put the negative 16. So y sub 3 is where we put the negative 16. We scroll all the way down to the smallest coefficient, where that smallest coefficient is 1. And it's okay if it's negative 1, because this is a negative number right here. So we're looking for 1. And then we want to find the biggest number, or the lowest number that has all whole numbers in y1, y2, and y3. Let's do the second example that we did, and let's see if that one works out with our little system here. So we're going to type in 15 divided by x, 15 divided by x. Oh, no. We want to do this. See how I did this in y2? Don't do that. It's going to mess you up. So the first coefficient has to be in y1. So 15 divided by x. Scroll down, and 20 divided by x. And we're going to hit enter. We don't want to look at the graph. We want to look at the table. So second table. And here it is. And we've only got 2, so we only are looking at these 2 right here. So what I said earlier was we want to find the smallest coefficient, which is 15. We want to scroll down y1 until we get to 1, so it's right here. And then we want to find the smallest whole number. So these are not whole numbers, not whole numbers, not whole numbers, not whole numbers, not whole numbers. There's a 0.5, which is not whole numbers. Oh, so when you're scrolling up, you got to be on the x. So we're looking for whole numbers, not whole numbers, not whole numbers, no whole numbers. Oh, there it is. The first row of whole numbers is 3 and 4. So this is our greatest common factor. Here is our new quadratic term, or our new term. And here is the last term. So this works. 5, 3, and 4. Now, it gets a little tricky because all the calculator trick does is give you the coefficients. You still have to figure out if there is an x that you can pull out. In this one there is, because there's 2 x's here, 1 x here. That's in common, so it becomes part of the greatest common factor. So you can use the calculator to help you find the coefficients of your factored expression, but you got to be careful with the x's. Ladies and gentlemen, if you need any help, please feel free to talk to your teacher, talk to your classmates. Good luck.